How are you doing today? We are in wastewater, water and wastewater laboratory techniques, chapter 5, and we're talking about temperature measurement. In your laboratory work as a water and wastewater operator, typically every day when you walk in, you will do a check of the temperature of your refrigerators, where either you keep the samples or a separate refrigerator where you keep standards or reagents at a cool temperature. So every morning I walk in, I get the lab book out, and I record the temperatures. That way, when the EPA comes in, they can see that yes, have been monitoring that the reagents and that the samples have been stored at the proper temperature. This will also, you'll have a thermometer at each sampler location. Inside the sampler, there will be a thermometer, and you want to keep that at 4C. And so you'll keep a notepad there at the sampler, and you will record that sampler. So we do a lot with measurement. On the wastewater side, we record the measurement on the outfall every day, and that is reported to the EPA. Temperature, so I'm going to highlight a couple things in this chapter. Temperature is a measure of the motion of molecules. Molecules that have a lot more motion are at higher temperature than molecules moving more leisurely. I like to refer to like when we're cold, we don't move as much or fast. And when it's summer, we're out doing a lot more stuff. Temperature is the same way, but we're dealing with molecules. So just try to put that into into a frame of reference. At the bottom of page 93, you'll see that there are three temperature measurements: Celsius, Fahrenheit, and the Kelvin scale. A lot of what we do in the lab is in Celsius, but it is important for your examination that you know how to convert Celsius to Fahrenheit and Fahrenheit back to Celsius, because that has been a test question often. 94. Temperature can be variously measured with liquid in glass thermometers, an electrical thermocouple, an electrical resistance, platinum or solid state thermometer, a mechanical bimetal strip, or an infrared sensitive meter. So there at the bottom, you have the comparison of the Kelvin and Celsius and Fahrenheit scales. So you know, a lot of what we have is absolute zero, is zero. The Celsius is negative 273.15, and then Fahrenheit is negative 459.67. Also, what is important is the water ice point. So, just to be familiar with it, that there are three standard ways that temperature is measured. On page 95, I want to highlight that it'd be the second paragraph down. All liquid and glass thermometers rely on the expansion of the liquid column with increased temperatures. These liquids encountered in glass thermometers are mercury, mercury alloy, and a variety of organic liquids. Um, Thermometers come in a variety of ways. So you have total immersion, partial immersion, and then complete immersion. So when you have a complete immersion, that is one that would be like in my refrigerator, and then there would be a sight glass that you could look through and um, see that reading. So it would be completely immersed in our refrigerator. Typically in the lab, we would use like a partial submersion for the lab, and then I'd open up the door and take a look at it. At the bottom here on page 95 is a liquid in glass thermometer. Just notice the difference. You have the bulb, the stem, the meniscus, the contract chamber, and the immersion line. You want to make sure what's important is, that you keep the liquid, the heat sink liquid that surrounds whatever you're measuring up to that immersion line. Turn over the page. We kind of have some enclosed chamber thermometers there on page 96. That why they're in a glass is because that's a heat sink. Because if I took that thermometer right out of the refrigerator, as soon as I start moving it to the outside so I could read it, obviously you can see I'm wearing glasses. Sometimes um, it is hard to read those because they're thawing. Um, I would put it in a heat sink there so that when I move it out, it's not going to rapidly change. That those those liquid filled heat sink or cold sink, whichever way you want to look at it, just keeps it at the temperature that is the correct um, get a correct and accurate reading. Within, this is very important in 96, within environmental laboratory thermometers calibrated by NIST or traceable or calibrated NIST thermometers are regarded as the standard. So, like for us, we will send out our thermometers in the lab or at our sampler, and they need to be NIST traceable. So, they would need to be compared against an NIST traceable thermometer as a quality control check. And then on the top of, let's say they are a little bit different, like degree different, you'll put a little flag, which is a um, paper on the top, usually with tape. What that allows the operator or operators that come in to know that it is plus or minus 1 degree traceable off of that NIST. You know that it's within plus or minus 1 degree of that thermometer, and then all those records should be kept in your lab for when you have your EPA um, inspection. Page 99. The bulb is the most delicate part, bottom paragraph, of the thermometer. Changes in the volume will affect the calibration. All bulbs age and will change volume. Um, they are made of glass, and glass is supercooled liquid, subject to creep and flow. The aging process is hastened by prolonged heating of the bulb, especially to temperatures above 250 Celsius. So once again, as bulbs um, get some age on them, they obviously will not um, read to the same accuracy as they had before because of age and just the fact that they've expanded and contracted. Bulbs are super delicate. I've broken many of them. So just keep that in mind when you're doing your quality control checks and you're using them on a day-to-day basis, that they are fragile instruments. I like to keep them with a metal jacket around them to kind of prevent them from breaking. I've seen that. Ways that you can check thermometers. So on page 100, a suitable ice bath is formed by shaving ice from the purest water available. The slurry is compressed and excess water is decanted. The bath temperature stabilizes after 15 to 30 minutes, and the thermometer is immersed to the appropriate point, and the temperature is determined. The auxiliary scale is provided for calibration checking on thermometers, so you can check them with an ice bath, or you can also send them away to another laboratory to have them checked. I hope this was a good little lesson for you. Sorry for the quality, but I hope you enjoyed it. Thank you.